Alright, so first thing you're going to do is just graph it like a regular equals equation. So standard form of y equals, just pretend that the sign here is like an equal sign. Next, what you're going to do is test a point. So that means you just plug in the x and y coordinates from that point in for x and y in the equation. Usually we're going to use the point 0, 0. Unless it's on the line. You can never use a point that's actually on the border line. And then once you test the point, if it works out to be true, you shade the same side of the line that contains that point. If you test the point and it gives you a false equation, then you shade the other side. Greater than or less than is a dotted line, so the line is technically not included, like in football, if you touch the line, you're out of bounds. The line is not included in the playing field. A less than or equal to sign is included. So that means, that's like tennis, where the ball can hit the line and that's still inbounds. Let's do one kind of easy one here. Y equals 4. So that's just this line. Everywhere y is 4. I drew a solid line because I treated it like a regular y equals equation, but it's a less than sign, isn't it? So that means that we're going to make it a dotted line. And then since I didn't actually test the point here, if I test any point here, let's say the point 2, 0, well, that's a really simple equation. Y is less than 4. Is that y value less than 4? Yep, it sure is. So we include everything below that line. Alright, let's try another one. So y equals, pretend this is y equals 3x. So y-intercept is 0, up 3 over 1, continue the pattern. It's a less than or equal to, so it's a solid line. Now, that actually goes through 0, 0, so I can't test that point. Let's pick any other point in the universe to test. How about the point 2, 2. So I plug in 2 for x and 2 for y, and that gives me 3 times 2 is less than or equal to 2. 6 is less than or equal to 2. Well, that is a false equation, which means I don't include that point in my shaded area, which means I do include all the other points on the other side of the line in my shaded area. And I'm actually going to have you get in the habit of just drawing some perpendicular lines here, just shading like that, because once you start doing multiples, it's a pain if you have a big, messy graph. Alright, so here's 2 more quick examples. Let's do example 7 here, and you can finish the rest of the page. You're going to do y equals, pretend this is just an equal sign, so the y-intercept is negative 3, and the slope is down 1, forward 2, right? Because the slope is really negative 1 over 2. Continue that pattern in the opposite direction. It's a less than, not less than or equal to, so you're going to just make it a dotted line. Test a point. The easiest point to test is 0, 0, so you plug in 0 for y and 0 for x. And that gives you 0 is less than negative 1/2 times 0 is just 0. 0 is less than negative 3. So I tested that point. 0 is not less than negative 3. Negative 3 is less than. That's false, which means I shade on the opposite side of the line. And just to give you an example of one that uses standard form, it's easiest just to graph with the intercepts. If x is 0, plug in 0. 0 minus 3y equals 6. Solve that equation. Get y is negative 2. And then if we set y equal to 0, then 4x equals 6. So that's 6 over 4 is x, which is the same as 3 over 2, which is 1.5. If you didn't like that way, you could also take it and just turn it into a y equals equation. Well, let me just graph these first here. So 0, negative 2 is right here. 1 1/2 or 3 halves 0 is there. Continue the pattern, over 1.5, up 2, down 2, back 1.5, and it's a dotted line. If you didn't like that, you could have just gotten it to a y equals, so that would be minus 4x on both sides, negative 3y is less than or equal to. Now you got to be careful if you do that, because you got to follow your inequality rules. Negative 4x plus 6. So now when I divide by the negative 3 to solve for y, I divided by a negative, and with an inequality equation, when you divide by a negative, you have to flip the inequality. So now it's y is greater than negative over negative is positive 4/3 x minus 2. So that gives me a y-intercept of minus 2, and then up 4 over 3, so that works. All right, now we test the point 0, 0. And that's 0 minus 0 is less than 6. That's true, so we include that in our shaded region because it worked out to be true, the point that we tested.